Next standard, it's all about dilations, which might be a good thing because we just kind of learned about dilations on the last test when we were doing similar shapes. The shapes all have the same angle measures, it's just one is a proportion of the other, twice as big, three times as big, whatever. And that's what this is all about, but we're going to add something to it. We're going to add distance to this. So let me just start from the beginning. Let's say this was last test and we had to say what was the scale factor that got this little triangle to that triangle. You'd have to see some numbers. Let's say this was 2, 3, and 5. Let me just make it legit since it's a right triangle. And if anybody of you out there are going to say that's not Pythagorean theorem, 3, 4, 5, that works. Let's say that one's 3, 4, 5, and this one's 6, 8, 10, just to make it easy. Then you would say the scale factor is 2. Well, sorry, I dropped my marker. All right, remember back to the transformations test, the reflections, the translations, the rotations. We had little prime marks by our letters. What I mean, if this triangle is ABC, then this triangle would be A prime, B prime, C prime. Those are back, people. They're back. And that just tells you where you started from and where you ended up at. That's how you know, is this scale factor 2 or was it 1/2? If you would have started here and shrank down to this, then your scale factor would be 1/2, and this triangle down here would have the primes. Whichever one has the primes is the one that you ended up at. The one without the primes is where you start from. So if you start from the big one, your scale factor is 1/2. If you start from the little, teeny tiny, cute one, then your scale factor would be 2 on this. Now, here's the new thing, the distance. What does distance mean? Well, dilations aren't simply just making things bigger or smaller in this standard, it's projecting them. Like this projector is projecting this image onto the screen. It's kind of like a flashlight. It starts at a point. And that point happens to be back where your corresponding vertices join together. So that point is right there. So this point right here would be like our flashlight. So let me try and draw a little fancy flashlight on 2 different slates. So that's our flashlight, and it's shining a light, and as the light goes farther away, it gets wider and wider. Now the scale factor for the distance is the same as the scale factor for these shapes. So we know our scale factor here was 2. We started off small, we got twice as big. That means this triangle is twice as far away from where it started from as this one is. So let's look at this distance right here. From our starting point, we'll call that S for starting point, to A. So the distance of SA, we'll say, is equal to 5. That means the distance of SA prime is equal to 10. That point is twice as far away from our starting distance as A, because the scale factor is 2. The scale factors work for distance and the individual shapes, which you already know the shapes. You guys all did well on that last test. Now you have to understand the distance thing here. So that distance right there would be 5. This distance from S all the way to A prime, that's 10. It's twice as far away. And that's really it. That's everything you need to know about dilations. This is just a matter of practice and getting this right. But I don't think it's going to take that long, which is good because we don't have a lot of time. So we got to rush through some tests here. This might be another one that we're rushing through. We're definitely going to take this test early next week, probably Wednesday-ish. But let me give you one more demonstration before I let you go to kind of demonstrate what I'm talking about when it comes to distance. Here's a big old triangle. That triangle is actually originating from the projector up on the ceiling. There's a projector. You can kind of see the the light right here. That's the projector light reflecting off. But anyways, I'm over here drawing this shape on my whiteboard, and the overhead projector then shines it out of a flashlight from the ceiling. And it shines it onto the whiteboard. So let me see if I can fit this on here. All right. As I bring this closer to the projector, that triangle gets smaller, smaller, and smaller, and this is not very dramatic like it is if you're in the classroom. Maybe I made that a little too big. Let me try and make this a little bit smaller. See if that helps. So there's my triangle. So it's projecting onto here. And as I bring it closer to the projector, you can see that that triangle is getting smaller and smaller and smaller, kind of. Yeah. I got a bunch of oohs and ahs from this last year when I did this in class, and it does look a lot better in person. You can see that it's getting smaller a lot easier than you can on this video. So I'm going to say I wish I wouldn't have done that for you right there, because I don't know, maybe it showed up better than what it looks, but it looked to me like it wasn't showing up that well. So all of you that are brick to click, you're not going to get to see that wonderful demonstration, but I'll show you guys that in class, and it'll make more sense.